Warm welcome, everybody. We're live here from Mobile World Congress in Barcelona from Ericsson's booth. Today we're going to talk about network technology. With me back in Dallas is Dara. Dara's going to take all your questions during the sessions here. So already warm up your keyboard, start typing questions as we go during the session here. And looking forward to have some talks, also getting in and answering your questions. So we have 6 different stops here during the session, and we hope to give you a good rounded view of everything going on the network technology side. But before I dive totally into Ericsson people, I got a dear friend and guest here, Peter Jarish, Head of GSMA Intelligence. Warm welcome, Peter.
Hey, thanks for having me.
Yeah. So I asked you to come here and talk a little bit, giving your perspective. You've been covering the mobile industry for a very, very long time. And we have a couple of very interesting technology shifts ahead of us. What do you see going on in the world when it comes to standalone architecture and that transition?
Yeah, I think it's no surprise. We've all been waiting for standalone, right? And I think it's taken longer than expected, but we're seeing 2 things. One, we're beginning to see momentum, right? You definitely see operators paying more attention to it. They understand the value, and they understand it's key to what they want to do, especially with B2B, right? We see a lot of optimism, but more importantly, we actually see those deployments taking place, right? When we talk with operators, we see the expectations of new SA networks incredible over the rest of the year, which is really important for things, again, B2B, but especially things like slicing, and we know that they want to do things like that.
Yeah, so is it fair to say that when we're getting to the point, we've got mobile broadband out there, we've got fixed wireless access out there, SA, one of the key drivers is network slicing and what we can do that, especially to trigger new monetization models.
It is. And I would like to stop and say, I mean, as much as I know we sort of dismiss sometimes EMBB and sort of talk about, well, it's okay, it is important. I mean, without EMBB, without 5G, we wouldn't have been able to meet all the traffic demands. So I think sometimes we talk about 5G not having the potential, but it's done incredible things. But yes, when we think about SA, slicing is so incredible. And I said this last year, I said, look, if it's 2023, and we're still talking about POCs and trials, we have a long way to go. And I was kind of disappointed last year. So this year, I mean, even just looking at the recent news, right? The work you guys are doing with BT, Telstra, the Telefonica announcement, particularly exciting. It feels like we've finally gotten to the point where slicing is something, we're understanding the use cases, but understanding how to make it work. And so I think I was surprised, but I'm excited to see that this might be the year when slicing actually starts to get some momentum.
I got exactly the same feeling because there's a lot of things, it's not necessarily new things, but it's all of a sudden the rubber is starting to meet the road on some of these key things. What are others? Are there any other things? You've been walking around here pretty much for three days right now, capturing perhaps more than anyone else. What else should we think when we're saying, I see 2024 as a little bit like the halftime show?
That's completely fair. Clearly AI, everywhere, right? And what I actually like about the AI story here is it's balanced. It's not just about Gen AI, right? We spent a whole bunch of time figuring out Gen AI, and that's the cool new hotness, but recognizing AI's been in networks for years, and we can put it to use in networks for improved energy efficiency, for improved network operations, and just seeing how we integrate it, particularly when we virtualize the network, right? And that's not just Open RAN, but vRAN more generally, and what that can do for automation, what that can do tied up with artificial intelligence, and how the ecosystem is ready to support that. I think that's been really exciting.
What do you see about operators, how they're approaching like the network evolution and the modernization of this? Is anything different from what you've seen in the past?
Yeah, I think it's tough, right? Because on the monetization side of things, they're a little bit worried about spending too much before they understand what they can do and how they're going to generate revenues, right? So they are sort of looking at this as sort of, how is it going to generate revenue? So it can't just be a saving side of things, right? So that side of things, monetization, as you said, is going to be key, which is why things like slicing, like network APIs, those are such a big focus because they can see that revenue opportunity and not just the savings opportunity.
And also starting to tie it to, perhaps you've done the base of building the network, but now for the expansion, actually saying, let's tie the expansion to expanded revenue opportunities.
100%. 100%. Now that you have that base there, how am I going to actually make money? And I think there's optimism, right, around APIs, around things like slicing, and a really push on B2B. and some of the opportunities they can leverage with AI.
Now we've seen a lot of conversations here. I think more shifting towards right now. A lot of the private networks, which has been coming along. Perhaps we already have to happen a little bit earlier. Stronger push on that one. So I think if we look at our booth here, like when we talk about this new consumer and business application, a lot of interest there. And
100%. When we went out and we talked to a lot of operators last year, and their B2B, really the B2B execs, right? And what's driving your B2B business? How do you see private networks? Is it going to be an up year, down year? There's a lot more excitement, right? The demand coming, and we see that. There was a great, I was just talking to Verizon earlier in the week and just talking about some of the use cases, right? And it takes a while, right? It's education.
Yeah.
What are the use cases? How does it work? The value, what you're going to do with it. It takes time to build it up.
Yeah, and it's like we can't really go to 5G in the elevator. It's like pretty much stairway to 5G.
That's exactly right.
Perhaps we're not that far away from heaven now.
I hope so. I hope so. I'm getting old. I hope that's where I go.
Sounds really good. Thank you very much for coming and visit us here tonight.
Thank you for having me.
Yep, safe travel back to the hotel and hope you get some nice, good tapas tonight. Excellent.
Congratulations, guys, on a great show.
Thank you. So with that first introduction, we're going to move over here and start with a little bit about the network evolution. And Hans perhaps know more about network evolution than anyone that I know. Hans, how would you put into perspective what we see ahead of network evolution, knowing that we started with non-standalone architecture. In North America, we put up a very large amount of massive MIMO in mid-band spectrum, and so on. What are the important steps that we have ahead of us?
Yeah, I think if we look at the demos that we're showing here and the proof points of the network evolution, we start with what we call the differentiated network.
Yeah.
And it's about actually getting our customers interested in these differentiated services. And I think it's good to offer, good availability. That is what you need. But you're also going to have to go into 5G standalone as the basis in preparing your network for, exposure, slicing, and those differentiated services that comes in the next phase, which is what we call the open API network in this proof point. I mean, you may refer to it as 5G advanced in certain markets. It may also mean that you need to go for a mid-band spectrum perhaps, or even low band, depending on the market.
Do you see that when we talk about the differentiated network and the fact that right now the networks need to pay more attention to the services that's going to go on, and especially the new services?
I think it does, and in several aspects. I think there is a value to be captured actually, offering services to the mobile broadband users, but also to enterprises. And I think we see the networks in several markets actually going into government services, enterprise services, and then security becomes very important, for example. Reliability, resilience, all of those things actually play a new role.
Yeah. So we've talked a lot about this, the network modernization steps, and we also talked a lot about cloud. We've gone through the virtualization journey, and now cloud native. What is happening on that side of the equation in terms of the best way to land all these capable network functions?
I think we've had this cloud discussion for some time, and it's been with us for a long time. And I think to a certain extent it's kind of being normalized or understood. Yeah. And I think the choices that you make today depends maybe on your service characteristics or the service needs that you have for what you're providing. Yeah. I think with Ericsson we support all of them. So we're working with both public and private cloud, and of course cloud native is going to be imperative for your network, which is another one of those stepping stones that you're going to have to take.
Yeah. What do you see if we look about the radio network? I think when we look at the US right now, we've done pretty much, or we have very good coverage in urban and suburban areas.
Yes.
Rural perhaps remaining, a lot of things going on indoor, and then also with this very dramatic increase in fixed wireless subscribers, starting to. How is that affecting the radio or the transformation of the networks?
Yeah, I mean, fixed wireless is big, and especially in the US, of course. Yeah. I think there will be ever-increasing demands. I think we see in the market still the need for indoor. Yeah. I think we see the need for, the coverage is still, when it comes to, government services, you're gonna require that. Maybe you need to actually think about how do you kind of safeguard parts of your network? Do you have a deployment model which actually makes it more resilient? Yeah. And then, of course, if you go indoors and you consider enterprises, yeah, I think that's another market opening up.
Yeah. So we talked about the differentiation of the network, but you're also very much talking about here the open APIs and the dynamic aspect of the network. What are all those things all about?
Well, if you prepare a network for going into the open API and you start with slicing and the differentiated services, you need the orchestration to follow that. On the API side, you start exposing the capabilities of the network through an abstraction layer perhaps. And then you would go into an aggregation layer. And in that way you can share the APIs with other operators. So you don't have to be alone, you could actually share some of that burden and actually create an ecosystem that is larger. And by that you will attract a larger pool of application developers. And that is really, if we look at the last phase, which you call the dynamic network, the purpose that you want to go to. You want to create a huge pool of application developers that can support your network and your services.
You've seen perhaps most of the things that we've been doing in the network over the different generation. What makes you excited about what we have now in the second half of the 5G deployment cycle?
I think from my personally, it's enterprise and maybe mission critical, and I think the resilience and the availability of the network. But I think another area that makes me really excited is how can we actually explore the value creation through the APIs? How can we make more use of the network as an innovation platform, for example? I think that is still to be done, and I think we are early still in the 5G area, even if I think I've spent the last good 8 years with 5G. I think we're still early.
Yeah.
So it is still exciting times before we get to 6G.
Sounds really good. Thank you, Hans. This gives us a very good backdrop for the rest of the conversation.
Excellent.
Here.
Thank you.
So we, in this particular session, we have now talked about the network transformation. On purpose, we left out a little bit about the Open RAN and what's going on in that particular area. So with me tonight, we got two fascinating colleagues here, Frank and Paul. We can talk a little bit about Open RAN. What does Open RAN really mean, and to Ericsson, and what are the key points that we're talking about here at the show?
Okay. So the Open RAN actually, we're not talking about just technology-wise Open RAN, we'll talk about industrialization of the Open RAN. There's three major pillars we want to work together to make this industrialization Open RAN work. One is the cloudification, which means hardware and software disaggregation. The second one is open interfaces. Third one, not least one, is the automation and intelligence.
That's really good. So when we talk about these different things, are they coming all in one go, or this is something that goes in multiple steps?
It's a journey. Open RAN is a journey. It's not a journey about design, but also a journey for CSPs, for our customers to pace out their modernization paces, and also journey with all the ecosystems going along with it.
Yeah. So Paul, you've been spending a lot of time with Open RAN over the last few years here. What do you see is happening right now in the market, especially at the backdrop of the announcements with AT&T in December? How is this changing, and what are the important conversations in Open RAN going forward?
So Ericsson's made a lot of commitments in Open RAN from Open Front Haul, and we see here this is the first time we're demonstrating a third-party radio. This is a Fujitsu radio working with Ericsson baseband, so our cloud solution as well as purpose-built baseband. This is the first time we're showing that. And that's a great proof point of the openness of Ericsson's network. And so then we also have the open interfaces on the radio, and we also have open platforms that enable automation. So all these pieces are coming together, and that's really demonstrated by our success with AT&T, and we're very happy and proud to be building an open innovation network for AT&T, and that I have all these open interfaces that allows an open ecosystem to be supported. And so that is, for us, a real business proof point of our open credentials.
So how would you say, where we're coming if we start at perhaps the first step, the disaggregation, and how long, what are the key things going on there?
So perfect timing for that. So this is our third-party server running on the Intel Sapphire Rapid EE32 core of the CPU. Is actually being quite some journey. As probably some of you know, the industry started with the Ice Lake quite some years ago. With the help from Intel, we bring up the latest CPU, Sapphire Rapid EE, enable us to be able to truly build a macro deployment scenarios in order to condense from two servers into a single server to support multi-rats, FDD and TDD together. together. Based on our assessment, it will be sufficient to support most of the macro large-scale deployments. In addition, the innovation did not stop from here. Thank you for the openness. Thank you for the hardware and software disaggregation. Intel is actually bringing up a next generation of the CPU called Granite Rapid, which was just announced earlier this week. We have a sneak peek of this in our demo station today. We actually managed to turn on the CPU and run an end-to-end solution in less than 3 weeks. Thank you for the software and hardware disaggregation.
So we have a lot of movement, development here, both on the disaggregation and the open interface. What about the orchestration and the automation of all of this?
Yeah, so one of the key pieces is automation. And so how is that enabled? And so in Open RAN, it provides a great framework. And so there's something called the Service Management and Orchestration Platform, SMO, and Ericsson has a product in that space, the Ericsson Intelligent Automation Platform. So that's the framework and platform to be able to automate the network with. So on top of that, we have applications. So think of an app store that control and help the automation of the RAN. So in these things called R apps. And so our apps then become an ecosystem, and we actually have 14 different ecosystem members that are all generating our apps or applications that help automation for our operators. So 14 ecosystem partners, as well as Ericsson R apps. These all work together in a multi-vendor environment to control the RAN. So why is that important? It allows me to automate the RAN. It allows me to optimize the RAN. It can do things like improve energy efficiency, spectral efficiency, so many things that we can control. It's all about software programmability of the RAN, and that's what we're so excited about with a great framework that enables it. A lot of these R apps are also packed full of AI intelligence, and that's really going to be some of the sort of secret sauce that allows us to optimize the network in a really good way.
Yeah. The other thing that I noticed, we made an announcement early in the week also with the O-RAN Alliance a little bit about, we talked about 2 different types of interfaces to the radios, Cat A and Cat B. How would you describe this to the audience? What is it that we're doing?
So I would say, so O-RAN Alliance defines these 2 interface types because they're talking to 2 different types of radio. So one type of radio we call the remote radio head, and that uses the category A or Cat A interface. So we fully support that. There's also a more complex radio, so the massive MIMO radio, that's really the muscle behind 5G in terms of capacity, a more complex radio, and requires a more complex interface. And we've spent a lot of time with O-RAN Alliance in really defining the right interface. We had to get it right. To industrialize the RAN, that interface between the radio and the baseband is really critical. And we started a project called the ULPI. So this is uplink performance improvement. So what that means is so traffic and performance from the device to the network, that's the uplink, is improved. So we took the first original spec from O-RAN Alliance and we put extra work to make sure that it was performance optimized. So that specification will come out in June this year, and we've already implemented that specification in our products.
One thing that I'm thinking about a lot, like we talk a lot about things that's going on in the network now. We're going to move to standalone architecture. We're introducing Open RAN, 5G Advanced. Where does Open RAN fit into this picture? How would you describe that?
Yeah, so clearly the industry right now is moving from 5G non-standalone to standalone, and that's a big journey in itself, and there's many operators around the world who are on standalone, but there's many more that need to get there. Why do I need standalone? Better performance, reduced latency, it enables slicing, and enables some of those 5G advanced features like RedCap, for example. So that's sort of a standardization approach. Separate, I guess, I mean, there's some relations, but a little bit separate, we have the openness journey, and that is the cloudification and automation and open interface that Frank talked about. And so that's sort of happening in parallel. And so there's 2 kind of paths in the industry that are happening, and we're on both journeys, and we're very excited to get going.
Right, but this is perhaps one of the most exciting areas of the field. So what do we have, back to you, Dara, do we have any questions coming in from the audience on these 2 first topics that we've been touching?
Hi, Peter. Yes, we do have a question, and I just want to remind the audience one more time, please type your questions in the Q&A box of your screen. We are taking live questions, and if we don't get to your question today, we'll be sure to follow up after the show. So, Peter, I'll ask the first question now. Does Ericsson Open RAN work with other processors, or are there vendor lock-ins?
So the question here is like, does the Ericsson Open RAN, does it work with different types of processors, or what is the strategy and approach for that?
So, thank you for the architecture design. We selected in the VDU, which we call that a selective function accelerator, which some people call that Lucas site, that enable us to run our VDU on a general CPU with a general accelerator without any vendor lock-ins. We have already showcased this can work on Intel from Intel Sapphire Rapid, which is the Gen 4 of the CPU, as well as a Intel Granite Rapid, and also it works same software code running on AMD as well. As also we're showcasing in this MWC floor, we're actually working with ARM to transfer to port our software towards ARM without line-up code changes. So therefore, we're not locking when it comes down to open video designs.
So I would say, just to add to that, so not only are you free as a customer to select your processor, you're free as a customer to select the server that's used. Is it an HP or a Dell server maybe?
Yes.
And then you're free to select your container as a service layer, your CAS layer, with different choices. So that's really the spirit of openness, and that's what we allow our customers to do.
Yes. So I think this is quite interesting, because then we're creating openness on three
Yes.
layers.
Yes.
On the disaggregation alone.
Yes.
So I'd say, the radio layer, we have the radios itself have open interfaces.
Oh.
The cloud layer, the Cloud RAN itself has a set of open interfaces. And the automation platform with the apps on top of that are also open. So it's a multi-layer, full open ecosystem.
Yeah. So how does this relate to what Ericsson has been talking for quite some time, Cloud RAN, and where does this fit into this picture?
So Cloud RAN is our true implementation of embrace all the open interfaces. As Paul said early on, from hardware perspective, CPU is totally open, and the server we have HP, we have Dell, CAS layer. Currently we support Red Hat, or also we have Ericsson's homegrown CNX, and also we're also showcase our work with the public cloud with Google. So this is a true open interface in our Cloud RAN design and all layers.
So some people call it virtualized RAN, some people call it Cloud RAN, but the key thing is that they have open interfaces.
Yes.
And the other open interface that we talked about here is to the radio, and the fact that we're working with external radios. What are the important things to think about that when you approach that now, when you're planning your network evolution?
So I think one of the main things is to make sure there's an interoperability plan. So the specification is written, which is great. So that gives us a framework. The next step is we're working on interoperability frameworks that really specify and select the options within that standard. Then we'll work with third-party radio vendors and as directed by our customers to complete that integration. So there's an integration process. Now, the other thing I would point out is there's a one-time process of getting it working, but there's also continued lifecycle management for that integration. So you've really got to think about it in the long term as software and hardware changes. How do you deal with those changes, and how do you make sure that you keep testing and make sure the end-to-end performance is always at the highest level?
I think we got some more questions from you, Dara, if I'm right.
Yes, we do have one more question from an audience member before you move on. They are asking, for 5G standalone, what do you believe will be the timeline to get to 5G SA?
So the question here, what do we think about the timeline from when to get to 5G SA?
So for 5G SA, so some operators around the world are already there. They have 5G SA. Some operators are still working on the challenge of the migration. One of the things is to make sure the device ecosystem supports it, which we have great device ecosystem support today. The second is to make sure that the core elements, the 5G SA core, is in place. And the third element is to make sure that the performance level is good, so that the transition is good from a user perspective on performance. When all those things come together, the migration can happen. In the US, there's an operator there, like T-Mobile, who already has SA, and then there are the other operators who have SA migration plans. So it depends, it's regionally dependent, and we'll see many more operators moving to SA, some more this year, some more the following year. It'll happen over the next few-year period.
Thank you very much. Thank you very much for both of you. This is a perfect context for helping everybody understand, I think, what is Open RAN, and more than that, where does it fit into the network evolution, and is it one big bang or multiple steps? Thank you very much, and have a great evening.
Thank you, Peter.
So we will also try to here get to the point of trying to understand a little bit, how does this affect the radio portfolio? And we have talked a lot about leading up to this show about what more open radio portfolio, more performance and more sustainability. So Declan, help us understand this. When we talk about more openness, what is it that we really mean?
Well, what we're doing is looking at having our radio portfolio to be able to be Open RAN hardware ready. So we've enabled this through the use of our Ericsson custom designed silicon that we design in one of the facilities is in Austin, Texas, where we designed the silicon that goes into each of these radios. So we've enabled, from a hardware point of view, every radio on this wall is going to be hardware ready for Open RAN, and as well as currently about 1 million radios, or more than 1 million radios globally, are already installed that are hardware ready for Open RAN.
This sounds very much as a strategy we've tested a little bit before when we had 4G radios, which were software upgradable to 5G from 2015 and onwards.
Exactly, yeah, no, that's exactly it. So these will be ready. These will enable our operators to make decisions later on, to purchase the radios now and be able to upgrade them later on to the Open RAN portfolio.
Yeah, thank you very much. Roger, we talk about more performance. Like performance is so critical for the radio network. Spectrum is a scarce resource, and so on. What is it that we can get out of this solution more when it comes to the performance?
Yeah, thanks, Peter, for the question. Similar to what Declan was saying, with the new Ericsson Silicon, we're able to bring in a lot more performance than in previous generations of our radios. And that is not just translated into more bandwidth, which is of course a big piece, a big component, as we have more TDD spectrum, as you mentioned, but also more bands being combined in a single unit. This is actually critical in our indoor environment, where we have multi-operator demands, neutral host demands. People are not just looking to do multi-operator with more TDD spectrum, but also multi-operator combined with a private network. And so combining those use cases on a single radio and hardware prepared on the IRU for Open RAN, exactly as Declan mentioned before, all these are advances are enabled by our brand new silicon. So we're very proud to bring that to market and then be able to share with our operators and partners that this hardware that gets deployed enable these use cases and protect it for future advances.
We're talking about performance here. This is both indoor and outdoor, and also, is it both uplink and downlink, or what's going on the performance? What are the performance attributes that we're looking at that's driving this agenda?
Absolutely. So on the outdoor radios, you can see that some of them now have even more branches for the uplink, and you're able to do more receives than transmits to enable more uplink heavy use cases. You might have seen some of you as you visit the Ericsson media and booth, some of our immersive AR applications. Those are applications that call for more uplink heavy use cases. We have uplink carrier aggregation that we're also demonstrating. So it's not just the silicon and the radio itself, but the combination of the entire solution with some of the RAN features that enable this higher performance, both in downlink and uplink.
Yep. But it's not, Sacheka, it's not only performance geeks and open geeks that are really enjoying these ASICs that we're using. What is happening with the power consumption, the energy efficiency on our solutions? What really matters there?
Yeah, so when it comes to sustainability and sustainability of our portfolio, there's two aspects, right? So it's a sustainability when the portfolio products are in use, so that's the energy efficiency aspects, but there's also sustainability of the products when it's developed, so that's embodied carbon, and we've actually made significant improvements in both aspects in all hardware, software, automation, and site solutions as well. So with radios, our portfolio has improved energy efficiency by at least 20%, while improving the embodied carbon footprint by over 40%. That's significant. Now that's just on the radio side. On the baseband side, it's more performance. We talk about more capacity while improving energy efficiency there as well. So in our latest Gen 4 basebands, we've gone from 60 Mbps per watt to 120 Mbps per watt. So you're improving energy efficiency there as well. And then we talked about software and automation, and we've continued to improve on our software features. With Radio Deep Sleep, we can even go more into deeper sleep. And the coolest part we've introduced now is automation. So one of the biggest challenges our operators have been having is performance and throughput degradation and user experience. And we've launched a fantastic intent-driven energy optimization solution called Automated Energy Saver, where we can in real time manage and orchestrate all the software sleep features while maintaining throughput and user experience. So we get the sweet spot of energy and performance of user experience.
So there's tons of ways here which we're saving energy, but how are we generating the energy at the sites?
Yeah, well, in terms of, so that's the site solution aspects as well. In terms of reducing energy consumption, we talked a lot. And then the next part is looking at what energy sources are available. Typically we have the grid, but now we can use lithium batteries that's used for backup as part of the regular operations. And then if we introduce renewables as part of that, now we have 3 solutions that we can intelligently manage to disconnect from the grid and operate a site as virtual power plants. And another part that we've discussed is actually how do we integrate this on a cluster level and be able to have a bigger pool of power to disconnect from the grid and make a case for revenue generation for sites as well.
That's really impressive. Thank you very much.
Thank you, Peter.
So here you've got a feel for what's going on in the product when in terms of the radios not only becoming open, they are already open. The fact that we are continuously chasing performance and beyond that, we're saving energy. But there's one key to the puzzle here, Scott, that we haven't talked about yet, and that's security. How is the security development evolving for everything we talk about in the advanced 5G networks?
Well, I'm very happy to hear you raise security because that's very important to build into our products. And with 5G security, we see it evolving very well. 3GPP has given us a very good baseline, and now there's a lot of attention being paid to what's called a zero trust architecture and aligning the 5G networks that we're building with the NIST, a US agency, their 7 tenets to have a zero trust. When we meet that, then we have a zero trust architecture.
That's really good. And I know you spend a lot of time, you've recently been selected for a significant position in the O-RAN Alliance. How is that whole aspect changing the game of the security side?
Yeah, so I was elected co-chair of the O-RAN Alliance Working Group 11 for Security. Oh. And there we are working to build in a zero trust architecture for Open RAN. We're opening the RAN. We're introducing new splits, new interfaces, new network functions, and with that openness can come new risk. We are expanding the attack surface. In fact, the O-RAN Alliance themselves have publicly acknowledged the open attack surface. But within Working Group 11, we've done a great job over the last couple of years expanding on the security specifications in the O-RAN specs. It is now much stronger security, and we're continuing to pursue that zero trust architecture so that we can protect Open RAN from internal in addition to the external threats.
No, but that's fascinating. I remember also we did a lot of work last year in terms of explaining security from a cloud perspective and everything that, well, it's not only the network functions themselves, but from a cloud perspective. Yeah. How has that developed since we wrote the paper last year?
Yeah, so progress is still being made. There's a lot of work to do there. We have, as you know, the shared responsibility model in cloud. Oh. And that's been typically applied by the cloud service providers for their enterprise tenants in the cloud. But now we're talking about critical infrastructure. We need a higher security posture for critical infrastructure in the cloud, and 5G networks is critical infrastructure. We need to make sure we are securing the entire cloud stack, preventing lateral movement through the cloud up to the applications, and then also lateral across applications as well. That work is still ongoing, but we're getting there in a number of different standards bodies, and we're getting really good guidance from different government agencies around the world, including agencies in the United States.
You touch upon really important questions here, the agencies, and like, since we're now talking about 5G is really critical infrastructure for some of the most, also government functions and defense sector and so on. Right. you're working, can you help us a little bit understanding a little bit what are all the different bodies involved here, and how much agencies do you need to listen to really get the picture together?
Yeah, and that's a good question because so many different agencies in the United States have weighed in on zero trust architecture. But for mobile, the mobile industry, there are just a fewer set of agencies we need to pay attention to. So the first one is CISA, the Cybersecurity and Infrastructure Security Agency. That's part of the Department of Homeland Security. They've produced the Zero Trust Maturity Model as well as additional guidance. CISA, in cooperation with the NSA, has what's called Enduring Security Framework, ESF, and that's a collaboration with industry. That's produced security guidance for 5G cloud infrastructures. Getting to the previous question you asked, that provides excellent guidance. I call it a playbook for how to securely deploy 5G in the cloud. Then, of course, we have the FCC, that's the regulator for mobile, and they have a government industry collaborative called CISRIC. The actual acronym is CSRIC. Insiders call it CISRIC. This is industry working with government to come up with specific recommendations for operators to secure their networks beyond what's in the standards.
Yep. No, but thank you very much. So I guess you got the wealth of knowledge to share with us, and I think this really helped us get the frame for a little bit the landscape of 5G security and how it's advancing. Dara, over to you for questions from the audience.
Hi, Peter. Yes, we do have one question right now, and I'll give everyone time if anyone else wants to ask a question to please type that in. But the question is, does zero trust architecture only support external and external threats? What about internal threats in the context of cloud native technology?
Yeah, it's external and internal. That's really the major point, or primary point of a ZTA, the Zero Trust Architecture. Traditionally, we have been securing our networks with what's called perimeter security, and we've assumed the adversary is always outside the network. And in traditional deployments, that's been true. But now, as we're evolving to cloud deployments, we're introducing new internal stakeholders that have access within the network. Then this introduces internal threats. And this is why we need to apply that zero trust architecture. It protects us from internal threats in addition to those traditional external threats. And a really good example of this is what's called advanced persistent threats. That's where you have an external threat actor, typically a nation state, gains presence inside the network, and once there, they stay dormant, collecting data, performing reconnaissance, and then they move laterally, waiting for a moment they can cause destruction within the network. So with a zero trust architecture, we assume the adversary's already inside the network. That's actually a quote from CISA. And if we take that thought process, then we start building in the security controls we need to protect ourselves from those internal threats.
Yep. Now, I find this area very fascinating because we're talking about a lot of architectural shifts here, and the shifts that you're talking about on the security aspects alone is a significant piece of the puzzle going forward, especially as the role of the network here is developing and becoming more and more advanced applications that we're running on top of, and perhaps even more mission critical use than we ever have been thinking about.
Yeah,
okay, thank you. Thank you very much, Scott, for sharing your wealth of insights.
Sure.
So, when we now have taken all of these different steps here in terms of the network, we've talked a lot about the architectural shifts and architectural shifts in multiple dimensions. We're doing a lot of these architectural shifts to be able to use the network for more exciting things. So I've got Mats and Monica with me here, and we're going to talk about network slicing and how network slicing has evolved since we first started talking about it. And when we talked earlier today, you mentioned a little bit like how the ecosystem have advanced. What is it really that has happened in the ecosystem over the last year here?
In the ecosystem, I think what we see is that we have on the device side, we have gotten URSP, which is the possibility to adapt services to the network connectivity when it's differentiated in different slices. That has evolved and now is becoming commercially available in the phones. On the enterprise side, we see more and more of that ecosystem emerging with enterprises wanting to use network slices for various business cases. So that is, I think, the new thing. Plus the fact that we have gotten all the pieces of the puzzle in place to set up the slices, to orchestrate them, to put them together in the network and attach them to devices and that piece.
So this is it fair to say here that the network slices, again, we started with core and then we added capabilities in the radio side.
Yeah.
And then what is really significant in development is that it's now also exists on the terminal side.
I would say so, yeah. Yes.
Could you help us describe a little bit, like if you're an application developer, how does this link when you have your SP into the devices? How does that help you take advantage of the slicing capabilities?
Should I go to this? Yeah, well, if you're a developer, you can, with your SDK, your development kit, you can now decide which types of, let's say, immediate video flows for immediate conversation in a game, for instance, versus download of files versus other things. I can tag those things differently, and these are becoming built into the development kits. And because of this standard, that mapping towards different slices will be done in a much more automated way than ever before. This makes that whole process a lot easier. I think that's a significant change. And it also enables you to tie into the app developer system where they would now tag things, they would put it in the app store. It would fit in to the telecom networks and become running on separate slices. They could have a better connectivity and a user experience, which is monetizable.
Yeah. So we have a significant development here on the device and application side, and also apparently that this is very clear that people of that side of the equation have been thinking really hard about what makes sense to introduce. What has happened and how far have we advanced on the slicing in the network?
The slicing in the network is available. It exists. We have commercial deployments in many markets across the globe, I would say. Particularly the last year or so, we have seen more and more solutions and use cases becoming truly commercial. One example recently was we have in Taiwan, they have connected ambulances for emergency services to a commercially deployed slice of exactly this type.
Yeah, and Monica, you've been working a lot with like the orchestration and the management side of the equation here. What is it that people should know and see when we talk about slices and from an orchestration and management perspective?
Yeah, absolutely. So I think the key message here is network slicing is natively born with 5G standalone in the core, in the radio, but in the management layer as well. And in the OSS BSS system, what we are able now also to handle is the dynamicity of network slicing with orchestration and assurance, because a slice needs to be put in place, configured end-to-end, but also at runtime when the traffic is using that slice, you need to be sure that is assured the service level differentiated related to the differentiated connectivity. Then we need to put in operation the capability to use onboard dynamically on the slice the customers based on their willingness to pay, both from consumer and enterprises. Automation and orchestration, again here, is the capability in the management system to catch the willingness to pay and with time to market and efficiency operationalize the network slicing. and monetize network slicing. A different type of business use case, different type of charging models are enabled when you have different type of services running in network slicing. The network has moved from all type of service to fit all to a fit for purpose, business purpose network. And this is where the management layer in OSS and BSS through the orchestration, assurance, charging and billing can complement the network slicing technology in core and run.
So when I listen to both of you, it sounds like here we have 4 moving parts: devices, core, radio network, and the management that are now starting to really play together, and all the pieces in the puzzle are there. And quite some time has been spent on trying to getting this right. Is this a fair assessment of where we think we are right now?
Yes, I think the technology, as Matt said, is in place. The business case, type of business case, initial business case, both for consumer and enterprise, are also in place. A few of them, again, the granularity of the business can scale above all also when you have dynamicity and automation and orchestration. We see now the need to start to scale because we see the need to the capability in the ecosystem already available. In the 5G core standalone, 40 worldwide live networks in the terminals, Android, Apple's commercial terminals enabling network slice in the traffic category to map, and ultimately the dynamicity and automation in the management system to enable the scale of the business in pair with the scale of technology.
Good. I guess you're tired of my questions now, but we'll take one from the audience before you're off the hook here.
Absolutely.
Yes, we just have one question. Why do we need slicing for private 5G networks?
So the question is here, why do we need slicing in private networks?
Need is a strong word. I think there is the demand that is coming from, again, our customers that based on the requirement, again, the type of service, it could be a hybrid mobile private network. Of course, security, isolation, local breakout of data, privacy makes the capability with a network slice to be deliver some type of enterprise private network with the network slicing technology and reusing the public network.
No, that's a really good reflection. And I think that we're starting to see here that also when you're looking at business critical applications in a private network, there's different levels of business criticality for a business.
Exactly.
So,
not
really good.
all the private networks can be fulfilled by network slicing, but some use case could be.
I mean, there are huge private networks like a factory where you have robots and you have a lot of different connectivity needs where slicing is definitely
really good. Thank you very much, both of you. Enjoy the tapas tonight.
Okay, thank
you. Bye.
So the final stop on our journey here will be very much on looking into the future. Ericsson spending a lot of time of articulating the vision for our industry vision and where we're going. And Christina and Christian have been taking a very active role both in developing it, and you've now been here for 3 days talking about this back and forth. What can you share with us that we should know?
Thank you, Peter. So we can share the industry outlook first. So over the next 5 to 10 years, we will see society and businesses evolve with energy transitions, adoptions of electric vehicles, autonomous operations, sustainability solutions, and of course, increased productivity. A trend that Ericsson pay extra attention to is the digitalization, of course, as the 5G network and its evolution is a key for the digitalization. Enabling technologies like AI, cloud, and mobile technologies are continuing to evolve, and so those will progress the evolution of the major digital trends that further evolve society and businesses. If we look a bit more closer into our mobile industry, we realize that smartphones are dominating the business today, and it is together with the best effort mobile broadband services. The industry is in search for new innovative services, and with Ericsson's industry vision, we will create a better climate to further help in this innovation for new services. When we talk to the ecosystem of actors like the hyperscalers, the tech giants, enterprises across various industries, they tell us that they would like to get access to quality of service for the connectivity. We also follow new technology communication trends like the immersive communication, and for that we also realize that quality of service is needed. Enterprises tells us that they would like to buy wireless connectivity as a service. They also express a desire to be able to have these new services much more easily available than today in a similar fashion as in the IT industry. For that particular reason, we are working with network APIs and network platform business model. They also tell us that we really need high-performance networks, but we have come to realize that it's not always they need high-performance networks. For some cases, it's also so that there are new capabilities needed, like positioning, new security postures, and also perhaps even more uplink capacity. And for that reason, we have come to understood that the best effort, one-size-fits-all model doesn't sustain. The future network needs to be differentiated, and with the differentiated network, it means that it has to be able to deliver performance-based business models. To summarize Ericsson's industry vision, it's a combination of technology evolutions and a progression of business model to cater for further and more easy ways to develop new services. And now we will leave over to Christian, who will more in depth describe the performance-based business models.
Thank you very much, Christina.
Yes, thank you. And all this that Christina describes will enable innovation. But for innovation to happen, for entrepreneurs to come up with new ideas and so on, they need to understand 5G. Our platform, the 5G, or the networks platform, the 5G, must be understood in such simple terms that someone who is expert in something else knows how to combine it. That's how innovation occurs. You have an existing platform plus a new platform, and magic occurs. So how can we explain 5G in the simplest way? And we tried in various ways, and what I will show you now is the way that we suddenly found resonates very, very well with enterprises and other people outside our business. So let me show you. We can characterize any kind of connection by first asking, what is the need on the receiving side? Does the data need to be used immediately, or is it buffered, like a video call, or is it a video clip? On the transmitting side, is it a fixed amount of data that needs to be sent, or is adapted? So an example of adaptive data is YouTube, that changes between high definition and standard definition depending on the channel quality. And YouTube is also buffered. So with 2 alternatives on the send side and 2 on the receive, we get 4 combinations. And we can, in essence, say that because all networks today and all plans are built for YouTube, video clips, kind of traffic, web, this is what all the networks in the world today do. And we're adding this capability. When we explain this to different industries, for example, the automobile industry, they say they get it immediately. This is much more easier to understand than throughput or latency, for example. When we show you can have adaptive immediate L4S, they say, wait, that's the one we would use for live camera feeds and video calls. When we explain fixed buffered, that's good for uploading log files over their activation. We show fixed immediate, that's good for heartbeat remote control, and adaptive buffered for entertainment video. Going into the gaming industry, adaptive immediate is great for cloud gaming. For traditional gaming, adaptive buffered can be used to download menus. Fixed buffered is good when you download the new terrain or the map you're going to race in. And fixed immediate can be good when you actually do the driving or fighting or whatever you do. And what is quite important here is that big gaming brands, acquisition cost is the biggest cost in the gaming industry right now. So they want to use their brands, the games that are so famous, on as many platforms as possible. And today they can port them between consoles and handsets and so on, but they cannot port them to the mobiles, unfortunately, the biggest platform, because the connectivity is not good enough. Maybe they are in some networks, but as the games can be downloaded in any network, they need to build them for the worst networks. One more use case, the video. Same thing here. If it's in front of a remote-driven car, or if you're casually watching video clips, you map them to different use cases. Now, if we take the network point of view, the benefit of being able to describe this in just 4 classes is that we only need to deploy 4 levels. So if we start by deploying 5G standalone in all areas of the network, and you deploy these performance classes, performance levels we call them now, in an area, you can essentially offer any use case. You no longer need to find the use case and then construct the slice. Now we can support all use cases. And if there is a use case within this that requires better performance than this, you can add new versions. For example, fixed immediate 2.0 that perhaps has even lower latency, for example. And okay, we can say to start, these characteristics are not very different from the best networks today, but we are here building a foundation so that each of these can start to diverge. We can go into latencies that are 5 milliseconds. We can go into throughput that are gigabit per second. We can go into plans that are really, really cheap. So let's talk about that. Today, you cannot charge infinite on the plan that everyone can buy because it must be affordable. Connectivity is a human right, but low latency is not a human right. So one way to do this would be to continue with the adaptive buffered charging per month, perhaps even cheaper and cheaper. And then the other characteristics can be charged perhaps first by month, later by hour, by user, by application. So here we see, to finalize, our industry vision is both a vision for the technology and the networks and for the business. And that's what we have combined here. So
I think this is really interesting. When I first heard this, there's a couple of things that stands out to me. The first one, that with 4 categories can capture pretty much everything, so it brings simplicity to the model. The second thing is that when you look at individual application, that each and every application is not hard locked to one of these 4, that they move between them. And the third piece here is a little bit like, why doing this? Yeah, this is essentially key to driving new revenues. Well, thank you very much for your time this evening. I know I'm standing between you and tapas, but we thought that this was a very good way to end the show here, describing Ericsson's vision to the future. And for all of you listening, this is the final show in our series here in North America. Monday, we had the opportunity to talk to you about consumer and what is going on in that area. A lot of conversation has taken place there. Tuesday, we talked about the enterprise applications and what is driving the growth there, both private networks, all new applications, and wireless WAN, and how APIs comes into the picture. Today, we're going through all the big developments from network evolution, the architecture, what Open RAN really means. And then at the end here, I think we've touched some of the most important topics in our industry. We've talked about network slicing for quite some time. You showed right here that it fits together from the whole piece now, from the devices all the way through the network, including the management system. And we also very much talked about here about the vision here. And I hope you're bringing something with you, because supporting all these premium services with 4 classes of service doing it in a way where each and every application can use a variety of these different things for different purposes, and that way enabling new business model. I think this is something I'm super excited about and looking forward to have further conversations about. I would also like to thank Dara, who has been keeping everything of this together in Dallas, interacting with you during the talks here. We hope that gives it more meaning to attend these sessions. And also Cien, that has been putting together all the program here together with me from Barcelona. And anyone that also seeing this, if you're watching this recorded, don't be shy of firing us a question or two if there's something that this trigger, for those of you that don't have the opportunity to see it live, but are looking to the recorded version. And with that, it's over and out, and it's a wrap from Ericsson here in Mobile World Congress in Barcelona. Thank you very much for your attention. It's been a pleasure to guiding you through this booth that I'm immensely proud of.